Hey guys, in this lesson we would understand the standard form of quadratic equation in details. As we know, a linear equation can be turned into a graph. Similarly, a quadratic equation can also be turned into a graph. Any of the three forms of the quadratic equations can be turned into graphs. Linear equation graphs are straight line graphs. However, whenever we would see a graph of a quadratic equation, the shape of a quadratic equation graph will look something like this, and the name of this is called a parabola. So the graph of a quadratic equation has a parabolic shape, whereas the graph of a linear function has a straight line shape. Now both of these linear and quadratic functions, they have originated from a parent function, and the parent function of the linear equation is y equal to x, whereas the parent function of a quadratic equation is y equal to x squared. We call them parents because in both of these cases, we do not see any numbers introduced into the equation. It's just the dependent and the independent variable. Here with the power 1 and here with the power 2. That's why this is the parent of a linear equation and this is the parent of a quadratic equation. Now because this lesson is about quadratic equation in standard form, and we know y is equal to ax squared plus bx plus c is a general standard form of quadratic equation. Whenever we have to turn this quadratic equation into a graph, we would always use what is called the table of values. So standard form to graph is always table of values. Let's understand how to turn a standard form of quadratic equation into a graph and how to answer questions related to it. The question that we are given is in the form of a word problem. Let's read the question first. The underside of a bridge is an arc that can be approximated by the relation y is equal to negative 0.1 x squared plus 10, where y is the height in meters above the ground and x is the width in meters from the center of the bridge. Graph the quadratic relation. So we have this quadratic relation. Y is equal to negative 0.5 x squared plus 10. We notice that this is a kind of a standard form because a general standard form equation is y is equal to ax squared plus bx plus c. Since in this given equation we are missing a bx term because we do not have any x with a power of 1. So that means this term is missing and we only have ax squared plus c terms in the given equation. When we have to graph this equation, we can use table of values for it. We put x here, we put y here. We always try to put negative, 0 and positive numbers for x because x is an independent variable. It's up to us what values to choose for x. So let's say we select a negative 4, negative 2, 0, 2 and 4 for x values. To find out the y value, we just have to sub in these x values into the equation to get the y value. So if we want to solve for y when x is negative 4, we sub in place of x negative 4. We get square plus 10. This would give us a negative 1.6 plus 10, which is equal to 8.4. We would put that value here. Similarly, we can solve for y when x is a negative 2 and we get a negative 0.4 plus 10, which is equal to 9.6. When we sub in x as 0 here, we would be left with y equal to 10. When we sub in x as 2 here, the value that we would get is 9.6. And when we would put 4 here, we would again get the value of 8.4. Now we would use this table to turn it into a graph. Let's say this is the grid. Now we would plot the x and the y values in the grid. X is negative 4, y is 8.4, which is somewhat going to be here. When x is negative 2, y is 9.6, that's going to be here, close to 10. When x is 0, y is 10. When x is 2, y is again 9.6. That would be somewhat here. When x is 4, y is 8.4. That would be here. So we notice that when we connect these dots, we would get a graph like this. This graph can further go down, but we would have to figure out where it is going to touch the x-axis. So what we would be doing is we would be extending this table. Let's find out the value of y when x value is negative 10. You know the equation is negative 0.1 x squared plus 10. So when we put in x as a -10, we get a -10 plus 10 that is equal to 0. That means when x is -10, y is 0. Similarly, when x is 10, y would be 0 again. We can solve it in the same way. So when x is -10, y is 0. And when x is a +10, y is again a 0. So this is how this graph is going to look like. And now this looks like a bridge. Now how do we figure out how many points we have to take is, we can just take first small number of values like we had taken it here. And then we notice that these values of y are very close. We have to complete the graph by touching to the x-axis. Therefore, we try to take a bigger number. If -10 and +10 would not have worked, then we would have moved further up. However, with -10 and +10, we are able to touch the x-axis and we are able to make this graph. Let's read the next part of the question, and that is, describe the shape of the arc. We notice this shape is a parabola. Because we have to describe it, so we have to give a little bit details about this graph. So this is a parabola, or the shape is parabolic, and we see this graph is symmetrical graph, and the symmetry that we see is about y-axis. And we also notice that in this graph we see a highest peak point. This is called a maximum point, because this graph is not going to go above this point, or the y value of the graph is never going to go above this point, as when it hits the point it starts coming down. Therefore, we can add that sentence here that this graph has a maximum point, and this is how we describe the shape of this arc. Next part of the question is, how tall and wide is the arc? When they ask us about how tall is the arc, that means what is the height of the arc. We always take it from 0, because the bridge height will be taken from the level ground, not from under the ground. So this height is 10. Now because it's a height, we would need units to put in there. So let's go back to the question and see what units are we given this distance in. And here we see that the height is given to us in meters. So does the width. So height is 10 meters. This part C also wants us to find out how wide is the arc. That means what is the width of this arc, and the width is always from one end of the graph to the other end. This part of the graph is 10 meters long. This part will also be 10 meters long, because it's 10 units on the left side and 10 units on the right side. So altogether we would have 20 meters width of this graph. Part C is done. Next is, we have to identify the vertex, axis of symmetry, and maximum or minimum point of this graph. So what do we mean by vertex, axis of symmetry, and maximum or minimum point is, whenever we see a parabola, there will always be a tip of the graph. That tip point is called the vertex of the graph. Vertex is always described with a point, and point would always have an x and a y value. The x value of the vertex is 0, y value of the vertex is 10. So vertex is 0, 10. Therefore, part D is, vertex for this parabola is 0, 10. Next, we have to find out axis of symmetry. Axis of symmetry has an acronym AOS. We can write it down as AOS. So axis of symmetry is nothing but the symmetrical line that is dividing the graph into two equal parts. Parabolas will always have an axis of symmetry, and in this case, the axis of symmetry is this line. When we write on the line equation for a vertical line, we describe it as x equal to the value that this vertical line is crossing the x-axis at. Since this vertical green line is crossing the x-axis at x equal to 0, so axis of symmetry is x equal to 0. Always remember, axis of symmetry is the equation of the vertical line that divides the graph into two equal halves. And whenever we write on the equation of a vertical line, it is always equal to x value from where the line is crossing through on the x-axis. Next thing that we were supposed to mention is the maximum or the minimum point. In a particular parabola, there can either be a maximum or a minimum point. In this parabola, we have a maximum point, so the maximum point is same as the vertex point because it is going to be the tip of the graph. So we would write down maximum point is 0, 10. If the question had asked us about the maximum value, then we would just write down the y coordinate of the maximum point. So maximum value is 10 in this graph. And this is how we answer a question when it is given in the form of a word problem, or if you're given directly an equation of a quadratic relation in standard form. First step is to always turn it into table of values and then turn the table of values into graph and then answer the questions from the graph.